This is Adam Griffin, and this is the second video for this week, and the question is number 57. So the question is, a rubber ball bounces, and we'd like to understand how the ball bounces. So for the first part of the question, it is being dropped and it is bouncing on the floor. So we have to draw a motion diagram of the ball during the brief time interval that it is in contact with the floor. So the only forces acting on it are obviously gravity, because it's going down, and the normal force, which is acting against gravity as it's touching the ground. But there's also the force of motion from when it was dropped. So it's inertia. So what this is from when it initially hits the ground. So it's still moving down because it's a rubber ball and it can be deformed. So it wants us to show the first 4 or 5 frames as the ball compresses, and then another 4 or 5 frames as it expands. So for the compression, we have our ball, and it's going down right now. So it hits the ground, and it just starts to flatten out. And when it expands, it does the exact opposite, because a rubber ball has a lot of elastic. It's very elastic, so it decompresses, so it starts off flat, and then gradually it regains its circular shape. So for the acceleration at each of these parts, it's moving down, and it continues moving down because the force of motion is acting more than anything else along with gravity. So at some point in between, the acceleration is it stops acting down on the ball, and it begins to act up. Even though it's still going down, it is not, acceleration is not instant, so it's not enough to overcome gravity and its inertia. So it continues to accelerate up, and eventually it gets to a point where the force of the ball expanding is not enough to counteract gravity. So it begins, or it's too little to counteract gravity. So gravity is acting more on it now, and so it starts to accelerate down, and that's why it bounces less high each time. So for part B, we have to draw a picture with the ball in contact with the floor and identify all forces acting on the ball. So when it hits the ground, just like in part A, we have our inertia, gravity, and our normal force. And as the ball flattens out, it wants to stay the same shape. So as it flattens out, on the sides, there's a tension force or an elastic force that is trying to reshape the ball back into a sphere. So that is what turns it back into a sphere and causes it to go back up, and we'll look at that again in part D. So for part C, we have to draw a free body diagram of the same instant. So the 3 forces, just like in part A, we have our inertia, gravity, and our normal force. And because gravity and our normal force are equal, our force of motion makes it so that the net force is going down. And then for part D, it asks us to write a paragraph in which you describe what you learned from parts A to C, and in which you answer the question, how does a ball bounce? So a ball bounces because when it hits the ground, it deforms, and the internal tension acts on the ball to return it to its original shape, which expands the ball and pushes against the ground, causing it to go back up. So as it flattens, it wants to go back into a sphere, so the height of the ball expands, and because there's only 2 directions for it to expand, one of those is against the ground, so it reshapes, pushes against the ground, and goes back up. And that is the answers to all of the parts for 57. Thank you.